In this particular lecture, we are going to discuss about the two most important engineering documents, P&ID and cause and effect. What are the relation between them? Whether P&ID contains some information from which the cause and effect diagram is built, or it is otherwise. What happens if there is a contradiction between these two documents? All these points are going to be discussed in this lecture. So we already know what P&ID is. If you still have doubt, you can go through the previous lectures and you can write in the comment box. So as you can see here, cause and effect diagram, as the name suggests, is contain causes and their effects. So this is an actual cause and effect diagram that I have shown in the left side. So each of the rows starting from here basically represents cause, and these are starting from here. So these are the effects. All of these columns, right, starting from here, all the columns, they suggest effects of the cause, right? So if there is a particular cause, right, and if the effect is present there, it is given by this dot, okay? And if there is no effect particular to this, so then that portion will be remain blank. So for a zoomed in version, please look into this, right? As you can see there, I have mentioned two causes here, and for these two causes there is a possibility of four effects, right? Now for the cause 1, if you see, there is no effect of effect 1. Effect 2 is there, but again there is no effect of effect 3 and effect 4, right? So if cause 1 happens, then effect 2 will definitely happen, and effect 1, 3 and 4 will not happen, right? Similarly, for cause 2, effect 1 and effect 4 will happen, but effect 2 and effect 3 will not happen. So this is just a generic example. For example, suppose there is a high level in the tank, and in the case of the high level of the tank, the inlet valve of the tank needs to be closed, right? So for that case, what will be your cause? Cause is your high level, right? So level high is a cause, and effect is closure of the inlet valve. So there is only one effect, right? In the same situation, suppose there is a increase in temperature, right, of a reactor, and you need to close the inlet valve also, you need to close the outlet valve also. So in that case, inlet valve will be, the cause will be the high temperature, high temperature, and effect 1 will be closure of one valve, and effect 4 will be closure of another valve, right? So this is how the cause and effect is basically built. And cause and effect is very important because this, based on this cause and effect, the logics of the safety PLCs are built, right? So if there is any error in the cause and effect, the same error is going to be reflected in the cause and effect diagram. And uh, and then it will go into the logics, and as a result, what will happen is our system will be faulty, and it will generate some false response, or there will be no response. So that is a very dangerous situation. So that's why we should take utmost care while preparing the cause and effect diagram. Now take an example. This example will clarify you how the P&IDs are built, and also at the same time what is the relationship, or how you can cross-check cause and effect diagram from the P&ID. So as you can see, this is the example of a particular vessel in which the vessel of the level is to be maintained. In the case of the high level, it may cause overflow. That is one of the situation. Another important situation is in the case of the low flow or low level. What will happen in the case of the low level? The downstream process gets impacted in a bad manner, or there is a safety impact whenever there is a level low of this particular vessel, right? So level should not be low in this particular vessel, right? So what is the logic, or what is the interlock that is, or the safety function that is present here? So obviously first there is a BPCS present here. As you can see, there is an LT01 which is connected to a level controller, and level controller is going to open or close the valve through LV01. So this is your BPCS control system. In addition to that, there can be alarms associated with that. So there can be high alarm, there can be low alarm associated with that, right? But even if BPCS and alarm, these two layers are unable to protect the system, in that case, there is a LT02 which provides a safety function. How it provides the safety function? LT02, in the case of the low level, the signal goes to the PLC, and this is defined by I1, and that actually actuates the on-off valve at the outlet of the vessel, which is defined as UV001, right? So if there is a low level in the vessel, what will happen? This UV001 will get closed, right? So as UV001 get closed, the chances of level going down is getting minimized, or there is no chance. So what is the cause in this case? The cause is low level, or LT02. And what is the effect in this case? It is effect is UV01 needs to be closed. So this is how it is written. So you can see this low level here we have put in the cause section, and what is the effect? Effect is this valve UV001, right? So UV001 gets closed, right? Now, for example, it is this control valve also gets fitted with a solenoid, right? In the case of the control valve, it is got fitted with also a solenoid, and that solenoid also get energized, right? During this activity, then that will be another effect also, and in that case, that can be also written here. So here you can see that effect can be then LV01, and this also gets closed, right? This also gets closed. So in this case, what happens? Our control valve gets associated with a solenoid, right? This is an additional thing. Sometimes that is put in the with the LV, but that is not a very good design, because then the segregation of the control layer and the protection layer is getting mixed, which is not a good design. But still, this is a chance is there. Okay, so sometimes in the P&ID, the cause and effect diagram is mentioned on the note section. There is a small mention of this kind of thing, this cause and effect diagram, very small, and that provide basically the cause and effect of that particular P&ID. So sometimes it is present, but otherwise, if you look through this diagram, right, if in the P&ID there will be these diamonds, right? So by looking into the diamond, you can have some rough idea about what is happening in this particular case, what is the protection. But still, you need to, but sometimes it does may not provide you enough clarity. So that's why cause and effect is there to provide you much more clarity. But again, you can obviously cross check between the P&ID and cause and effect, and there will be situation where you will find that there is a mismatch between the tag numbers or some other things between the P&ID and the cause and effect diagram, and that is when you should point it out, and there is a major concern. Okay, so now hope you have understood what is the P&ID, what is the cause and effect, what is the relation between them, how you can really build a cause and effect, and how you can cross check the cause and effect with the P&ID.